Hello, my dear students. Today we shall revise or study once again some of the facts about the molecularity of the reaction. So, molecularity is a theoretical concept. Molecularity is meaningful only for the elementary reaction. Molecularity cannot be zero, cannot be negative, cannot be fraction. Molecularity more than 3 or 3 are very rare and are the slow processes. For complex reaction, molecularity has no meaning. Molecularity of the slowest step of mechanism of reaction is the overall order for the reaction. The number of reactant, this is the definition of molecularity. We are going to study it once again. The number of reacting species taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called molecularity of the reaction. From the above definition, we can easily conclude that reactant molecules have to collide with each other to give the product. So here the collision between the reactant molecule is very important, or it is considered to be very important. So now we should know more about the collision of the reactant molecules in detail. To study the collisions, we have a new theory which is known as the collision theory. This collision theory was developed by Max Strauss and William Lewis in between the 1916 to 1918. We should write here in between the year 1916 to 1918. Collision theory is based on the kinetic theory of gases. So here we'll study the collision theory in detail. So points for the collision theory. Number 1, according to the collision theory, reactant species, they may be atoms, ions or molecules, collide with each other to give products. But all the collisions are not converted into products. So now we'll study few terms. The first term what we are going to study is known as the collision frequency. So let us study the collision frequency. The number of collision per second per unit volume of the reaction mixture is known as the collision frequency. So in the reaction mixture per unit volume, the number of collision takes per second are known as the collision frequency. Collision frequency is denoted by the symbol Z. Now we have to study the factors on which this collision depends upon. The collision of reactant molecules actually depends on two factors. One factor is known as the energy factor, another factor is known as the orientation factor. So first we need to study the energy factor. To understand the energy factor, we need to understand some terms. So the first term that we need to understand is known as the energy of reactants. So these reactant molecules already possess some energy, and this energy is considered as the energy of reactant molecules. So energy possessed by the reactant molecules is known as the energy of reactants. This energy of reactants is represented by ER. Actually, all the reactant species do not have same energy, but by energy of reactant we average energy of reactant. So by energy of reactants we means, this is correct, we mean average energy of reaction. So we add all the energy of all the reactants and then we take average of it. Now we have the new term which is known as the threshold energy. Threshold energy is the minimum amount of energy with which reactant molecules collide so that they can be converted to products. So when reactant molecules collide, they should have some minimum energy so that their collision can be fruitful and this collision can be converted into products. This minimum amount of energy is known as the threshold energy. So reactant molecule possessing energy less than the threshold energy, even if they collide, they cannot be converted into products. So with less energy than the threshold energy, the reactant molecules if collide, they cannot be converted into products. If energy possessed by a reactant is less than threshold energy, that means ER is less than ETH, we need to provide energy to the reactant molecules from outside so that the energy of the reactant molecule increases, and then if they collide, their energy is more than the threshold energy and they can be converted into products. So now we need to understand the new term which is known as the activation energy. To get the products from the colliding reactant molecules, the energy provided from outside, so that energy of the reactant is more than the energy equal to the threshold energy, such energy is known as the activation energy. So here I have written for you, my dear students, such energy provided from outside is called the activation energy, denoted by EA. So mathematically we can write threshold energy is equal to energy of reactants plus activation energy, and therefore activation energy is equal to threshold energy minus energy of reactants. In other words, we can say the definition of activation energy: the difference between the threshold energy and energy possessed by the reactant molecule is called activation energy. Those reactant species which have energy more than or equal to the threshold energy, if they collide, they can be converted into products. Here an important note, my dear students: if a reactant species has energy more than threshold energy, we have a reactant species which is having the energy more than the threshold energy. If it is not sure that it will be converted into products, so it is not said that if they collide, if the energy of reactant species is more than the threshold energy, it is not sure that if they collide they will be converted to products. It is not sure that if they collide they will be converted to products. It may or may not be converted into products. We need to consider another factor which is known as the orientation factors. Thank you. We will study the orientation factor into the next video.